This video features Mech-Q's General BOM materials. In it, you'll see how to customize this powerful yet flexible software tool to generate custom weld mapping tags and tables to add to your CAD drawings. This data can be used not only for fabrication, but data consolidation and archiving as well. To do this, you'll see how to set the text height in model and paper space. You'll also see how to customize a Weld Map table to match your company's needs, as well as how to load the custom pulldowns to enhance database integrity and speed up the data entry process. We'll use the hot water return manifold from our boiler skid project shown here highlighted in pink for the demonstration. Let's turn off the other piping and equipment and use the piping import-export utility to export the manifold. Before we start setting up the bill of materials, we'll need to see what our dimension text height is. We'll type DIM on the command line and see what our text height is for the dimensional style we'll be using to dimension our pipe spool. We see here it's set to 1.25 inches. We'll click OK and exit the dialog box. Now we can set the text size. When we click on the BOM configuration button, the dialog box reads the existing setup file from your computer's permanent storage. These setup files are saved separately from the drawing settings and therefore once set can be used on any of your future drawings. We see here there are 4 settings that control the size of the text items for the BOM. The BOM table row height, the BOM table text height, the balloon text height, and the balloon diameter or size. First we need to set the BOM table text height. Since our BOM table will be placed in paper space and we want to plot a text height of 1/8 inch, we'll enter 0.125 inches here. The BOM table row height setting sets the spacing of the grid lines of the BOM table itself. Since we're using a text height of 1/8 inch, we'll need a grid height somewhat larger to provide spacing for pen width and readability. We'll use 0.175 inches here. While there are many ways to set up text sizes, for this demonstration we'll set it equal to the text size of the dimension style I used to dimension the manifold. In this case we saw in the dimension dialog box it was 1.25 inches, so we'll enter 1.25 inches here. We'll enter a balloon size of 2 inches to accommodate our 1.25 inch text height. Now that we have the settings entered, you should know that these settings represent the text height, grid spacing, and balloon size with the DIMSCALE set to 1.0. The BOM table grid spacing, table text height, balloon text height, balloon size, and arrowhead size will increase and decrease with the DIMSCALE as shown here. With the DIMSCALE set to 1, the text height is 1.25 inches as we saw in the dimension dialog box. As we increase or decrease the DIMSCALE, the BOM balloons and text height as well as the BOM table will increase and decrease as well. This means that once the sizes are set in the dialog box, if you need to use different balloon sizes, simply change the DIMSCALE. This allows different balloon sizes within the same drawing. This is extremely useful when plotting details at different scales. While we're setting the bill of materials text height, let's look at the piping bill of materials alongside the general bill of materials. We can see that both bill of materials have identical text height settings. This means that if we install Weld Map tags with the same DIMSCALE we use for the pipe tags, we'll have identically sized balloons, which will avoid recalculating the DIMSCALE for each type of tag we're installing. Like most spool drawings, this one is displayed at a best fit zoom factor, which means there is no formula to figure out the model space to paper space ratio. Therefore, in order to figure out the proper DIMSCALE, I place the dimension in model space. Then I switch to paper space. Next I adjusted the viewpoint to get the view and magnification factor I wanted to use and measure the text height in paper space. Now that we know the plotted text height at this magnification factor with a DIMSCALE of 1, it's a simple calculation to figure out the DIMSCALE for tagging and dimensioning. We see here that the text height in paper space with a DIMSCALE of 1 is 1/2 inch. We want this to be 1/8 inch, which is 25% of the current dimension text height, so we'll set the DIMSCALE to 0.25 and we'll get a plotted text height of 1/8 inch. If you want it to be a little larger or smaller, just adjust the DIMSCALE until you're satisfied. Let's go back and check our final settings. The text sizes are correct. The settings on the right side of the dialog box are set but can be changed to suit your needs at any time. But the settings on the left side must be correct before we start tagging. First, make sure that the full item detail included with the BOM balloon is checked. The BOM table formed from BOM balloon detail is checked. The BOM spans multiple drawings is unchecked. The show quantity greater than 1 with balloon is checked. And a form BOM from user blocks attributes is unchecked. Since we want a header for our BOM, the header toggle should be checked and the double line should be unchecked. Now click Apply to save our new settings. Now that we have the text sizes set, we can set up the Weld Map table itself. Since the Mech-Q General Bill of Materials files are independent from our drawings, we can use the existing Weld Map table in an existing drawing as a pattern, even if this table was not generated using Mech-Q. When we first open the dialog box, we may see something like this. Click on the Clear button to clear the existing fields. Let's start adding our fields. The first field is the tag number. To set the width of the table, we could use some laborious calculations involving text height, but since we can see that the lengths are satisfactory, let's use the pick function and speed up the process. You should be aware that the field names will also be the column names shown on the BOM header. This can sometimes be a problem since they cannot contain spaces or special characters as shown here. We'll see several ways to work around this restriction later in the video. Since creating the rest of the fields is the same, let's skip to the last data field. You should know that each BOM template must contain a tag number field, which we already have, and a quantity field, which we see here. Since each weld is unique, this quantity will always show as 1 on the BOM table. Now that we have defined all of our fields, we'll save our template file. Click OK and Apply. Now we're ready to install the Weld Map tags. First we'll set the DIMSCALE to 0.25, which we figured out earlier. Some CAD engines require the first Weld Map tag to be installed with the World Coordinate System current, which is what we have done here. We'll install the first tag here and check to see that the settings are correct. We are using capital letters, the tag letter is A, and we will be adding the tag to the BOM. Once we finish installing it, we get this dialog box, which at this point has blank pull-down menus. Let's use this opportunity to enter the data that we already know to fill out the pull-down lists. When we want to add a new item to the list, we click on Add New, and the BOM New Item Child dialog box appears. We'll enter the first weld procedure we'll use here. Next we'll add a new weld description. It's a 4-inch butt weld, so we'll enter it. Note the description pull-downs cannot contain a quotation mark, so I'll use an IN notation instead. On the X-ray required, I'll add a no to the list. For the X-ray complete, I'll enter an N/A for ease of use later. For now, that's about all the information we know, so we'll make sure the Add to BOM Table toggle is checked and click OK. We'll right-click to exit and erase the new tag. Now we're ready to start adding our Weld Map tags. Since we're working in 3D, we'll need to set the UCS to the proper orientation. As you can see, I installed the pipe tags parallel to the pipe's axis. For clarity and contrast, we'll be installing the Weld Map tags perpendicular to the axis in a stop sign or billboard type orientation. To do this, we'll use the UCS alignment tool. If you're creating 2D drawings, you can skip the UCS alignment procedure since it's unnecessary in two-dimensional drawings. All other tag placement procedures are the same whether it's 2D or 3D. We'll pick the node on the end of this flange. We'll drag the cursor in this direction for the positive Z-axis. We can see the XY axis is in the correct orientation, so we can install the first tag. We'll pick a point near the weld but won't snap to it. Now we'll pick the second point, then right-click to terminate the leader portion. Now we can start to add the data to the tag using the pull-downs we filled out previously. Since we'll be adding the Weld Map tags along the pipe run, we can simply leave the UCS orientation as it is and move its origin to the next weld joint using the UCS origin icon. We'll pick the appropriate place for the leader, place the tag, and fill out the appropriate information. Now we simply repeat the process until we reach the end of the pipe run. When we want to change the tag orientation, we'll use the UCS alignment tool, setting the origin point at the weld's node and pulling the Z-axis down the length of the pipe. When we get to the threadlet, we'll need to use a different weld procedure, so let's add that now. Since the viewing angle of the model is relatively low, adding the Weld Map tags parallel to the horizontal plane may make them hard to read. So we'll make these next two parallel with the pipe's axis. One last tag and we're finished. Now we'll switch to paper space, where I've already installed the piping BOM. Make sure that the DIMSCALE is set to 1 to ensure that the BOM table is made with the proper text height for paper space. We'll pick BOM table from the pull-down and right-click the mouse to make the table from the balloons in our drawing. When prompted, we'll pick a point along the border for the BOM's location. For clarity, I'll switch to my plotting layer settings. I'll place the header at the top of the BOM and make a few adjustments to it. We can see that the header text is a little too wide for the column width, so we'll use the Attribute Mirror Scale tool. Since we don't want to mirror the attributes, we'll type a U on the command line. For the new text width, we'll enter 0.55. This will make the text width a little more than half the original without affecting the text height. Now we'll just move the Weld Map table. One final item that needs to be addressed before we're ready to plot is the heat numbers. Since Mech-Q piping doesn't directly support heat numbers, we'll use the code column for the heat number. To do this, we'll first use the ATT edit command to change the code label to read heat number. Then we'll use the attribute mirror scale tool to make the new text fit in the column. Now we're ready to plot the drawing. In this case, we'll make a PDF file and send it off to the shop. With the drawing complete, we'll send it out to the shop so the manifold can be built. Once the manifold is completed, we should get the shop copy of the drawing or welding procedure sheets back that looks something like this. It has a note penciled in, the welder's name, cert numbers, and inspection information filled in with varying degrees of uniformity. Now we'll transfer this information to the drawing file for permanent record keeping. To add data to the Weld Map tags, we'll use the tag editing tool. Now that we have complete information from the shop, we can fill in the pull-down menus as we are completing the tags. Adding to the pull-downs is the same during the editing as it was during the initial installation. I've added the missing information to the other welds and the new welder's information to the pull-downs and skipped forward to the threadlet. We can see on the shop drawing a different welding procedure was used than was originally specified, so I'll add it to our pull-down menu and save the changes. Now all we have to do is rerun the BOM and adjust the header. First we'll adjust the title width as we did earlier. Next we'll make some of the header titles a little more readable for future use. We'll use the ATT edit command to do this. Now we'll resize the attributes and the Weld Map portion is complete. One final issue is adding the heat numbers to the pipe and fittings. To do this, we'll first use the tag editor to change the data in the pipe block itself. We'll start out with the pipe first. To edit, select the pipe to be edited and enter the heat number. Then click Save to save the changes. Since although the pipe has the same heat number, we'll use the Copy button to copy the heat number to each piece of pipe. I used the same procedure for the fittings as well and reran the piping bill of materials, this time with the Add Balloons toggle unchecked. Now that all the Weld Map information is stored in the drawing, it can be shared with others and also be exported with both the General Bill of Materials and the Piping Bill of Materials for record keeping via the delimited file format. Now all we need to do is plot the finished drawing for the record drawing set. Once again, we'll save it as a PDF file. Most of the first part of this video was spent setting up the general bill of materials to use for weld mapping. Let's see how to use it on a smaller sheet with a different zoom scale. Since the data for the pulldowns is contained in a separate Mech-Q file, the welding procedure numbers and welder's information will be available in all future drawings. It's now a simple matter of adding the correct data to the fields or adding new data to the pull-down menus as necessary. No setup or adjustment to the BOM table is necessary. We'll use this simple spool to review the text size process and see the reset button function. I've dimensioned this spool with the DIMSCALE set to 1. I've zoomed to the scale that fits in the space I have available on my sheet. Now we'll check the text size and paper space. We see that it's 3/8 of an inch. Since we have a little extra room in this drawing, let's make the text size 3/16 of an inch. So we'll just set the DIMSCALE to 0.5. We'll make model space current and enter the dimension subcommand. To change the dimensions already in the drawing, we'll just type update and select the dimensions we want to update. Since the BOM tag size is tied to the DIMSCALE setting, all we need to do is install them as we saw earlier in the video. Before we do that and finish the drawing, we should look at the reset button. If we open the BOM configuration dialog box, we see that once the BOM tags and tables are installed in the drawing, the tag and BOM size fields are grayed out, preventing us from changing them. This is because the tags in the BOM tables are blocks and need to be redefined. To do this, we'll use the reset button. The reset button is normally used when testing a new BOM setup while inserting test balloons in tables. It allows us to change the symbol shape, column or balloon size versus text size of our BOM items. However, it will erase all of the tags and BOMs in the current space, either model or paper. When we click the reset button, this warning appears to let us know about this fact. I'm currently in model space. When I call the BOM configuration dialog box and click the reset button, all of the BOM tags will be erased and the appropriate settings will become available for editing, in this case the BOM balloons. When we switch to paper space and click the reset button, the BOM tables will be erased and their settings will also be available for changing. I've tagged the drawing and regenerated the BOM table, but I'm not satisfied with the BOM header. This is because we're somewhat limited on its appearance due to the restrictions of the General Bill of Materials program. To get the header we want, we'll erase the stock header and insert a block that has exactly the headings we want. This one has a separate section for fabrication and inspection. It also has a two-line feature that more clearly labels the X-ray fields. As you can see, once the General Bill of Materials is set up, generating and editing a spool drawing with Mech-Q, complete with weld mapping, is fast and easy. Customization of the Mech-Q General Bill of Materials makes it one of the most versatile weld mapping products around. Since 1992, Mech-Q software has been helping engineering professionals with project concept and design, visualization, fabrication, data archiving, and project completion. The Mech-Q General Bill of Materials is available only in the Mech-Q software suite and is compatible with all reputable CAD engines. The Mech-Q software suite is available from cadavenue.com.